Good evening, my dear students. So today it's time to start a new chapter in class 11, mathematics. We'll start with chapter 9, sequence and series. Sequence and series. A part of this chapter has been already done in class 10, 10th standard. We have already done sequence and series. We have done arithmetic progressions, if you remember. So today we will be doing geometric progressions. But before that, welcome back all of you. Before that, please get your pen, paper, books, everything ready. We will be just introducing the topic geometric progression today, and then I'll be giving you some very important properties based on geometric progression, as well as I'll be giving you some very useful properties, of course, which will be handy as we continue. So you can just kindly bring in your book, pen, paper. We'll try to solve some questions from the exercise also today, just a few from the introduction part. So we can just get everything ready as we begin. So, alright then, so it's time to begin. I believe all of you are studying well. Time is slowly running out, especially for Nagaland Board of School Education. You have hardly a month left. But nevertheless, that's still plenty of time. That's still plenty of time for us to study. So never give up. Do continue with your studies. Hard work always pays off. So you should never give up. You should never be discouraged. Even one day is a lot of time. Okay, so you can make up a lot. So instead of just sitting idle and dreaming and thinking will not help. With that, none of our problems will be solved. Problems we always have to face. Always be ready to face the problems. Then definitely. And some of us may not have studied maybe for a very, very long time, but it's okay, no problem. Nevertheless, you still have, count the days, you still have more than 30 odd days. That's a whole lot of time. Okay, so please do pick up your pen and paper and then just start sitting on the table and then start studying. Alright, so let's continue with the topic of sequence and series, chapter 9 from class 11 mathematics, NCERT textbook. So fortunately or unfortunately, this year the first part of the topic, arithmetic progression, has been reduced from the Nagaland Board of School Education syllabus. I believe it's slightly similar to the CBSE syllabus, reduced syllabus also. But that's all right, because a part of that arithmetic progression we have already studied in class 10th standard, in the 10th standard. So it's almost the same, it's just that we had to learn some more properties on arithmetic progression. So maybe when you get time, you can just go through some of the books, some of the properties. Definitely in the future you are going to need, maybe for this examination you might not need that for the examination point of view, but knowledge is very important. The more you learn, the better you become. So knowledge is very important. The more you learn, the better you become, and knowledge is meant for sharing, not for keeping it for yourself. Alright, so now, as we all know, what is a sequence? So as we have studied in the previous classes, in the 10th standard and all, what do we mean by series? The series is nothing but a succession of numbers arranged, in a definite order. A sequence is a succession of numbers arranged in a definite order according to a certain given rule. I'll not write down the definition because we've already studied that, but we all know what is a sequence, isn't it? A succession of numbers arranged in a definite order according to a certain given rule. That's what we call a sequence. That's what we call a sequence. And there are some sequences which follow again certain patterns, and they are called progressions. I'll not be stressing much on this because this we have already, as I say, we have already learned in the 10th standard. That means all sequences are progressions, but all progressions cannot be sequences. Like for example, a sequence of prime numbers. So they follow a definite rule. No? They follow a definite order. They follow a definite rule. A sequence of prime numbers: 1, 2, 3. Not 1. Sorry, 2, 3, 5, 7, 11, 13. So this can be called as a sequence of prime numbers, but not necessarily a progression, because progression will also follow a definite pattern. So here a pattern is not followed. It's just that it follows a definite order, a definite rule, sequence of prime numbers. Progression will be like, we have different kinds of progression. So a progression, of course, will follow a certain pattern. Maybe as we have seen in arithmetic progression, a progression, a sequence in which every consecutive term or every successive term gets added or subtracted by a same number, by a constant term, which was called as common difference. That was called as arithmetic progression. A sequence in which every successive term continues to add, is added or subtracted by the same constant term, which was called as common difference. It was known as arithmetic progression. Now here we will be learning the second type of progression, that is the geometric progression. So in arithmetic progression, what did we learn? We learned that again, every successive term is added or subtracted by the same constant term. That constant term was called as, or denoted as, D, which was known as common difference. Now here in geometric progression, okay, getting back to that sequence and progression, so I hope you have understood. Sequence just follows a definite rule or a definite order. Progression follows a definite pattern also. That is like, there should be an addition of consecutive numbers, there should be multiplication of the constant term to the successive by a constant number with the successive term. So there should be a definite order. Either it's increasing constantly or it's decreasing constantly, or we have a common ratio that gets multiplied, or the common power. So there should be a definite pattern. A definite pattern, it should be following a certain pattern. Now coming back to progressions, as I was saying, we have already learned what are arithmetic progressions. So now in this class 11 standard, what we will be doing is we will be learning a new type of progression that is known as geometric progression. But before we really go into geometric progression, we just discuss, let's just try to recap some of the small things that we have learned in arithmetic progression. What were they? What was an arithmetic progression? A sequence in which every successive term is added or subtracted by a constant term, known as the common difference. First term we generally denote by A, not necessarily, that depends on the textbook. Letters, really, you can use different letters also. The general term of an arithmetic progression was given by A plus n minus 1 into D. That was the general term. We have seen how useful is the general term for calculating finding out which number of terms for calculating that particular term, nth term. So this is how it is useful. Then of course we also had how to find out the sum of n given terms of an arithmetic progression. That was given by n by 2 twice of A plus n minus 1 into D. So this was the way to find out the sum of n terms of an AP, or the other one we also had n by 2 A plus L, where if we are given a finite progression, then L represents the last term. Then of course we also had the arithmetic mean. We also had the arithmetic mean. Arithmetic mean means if, let's say, if arithmetic mean, if we have three numbers A, and B, which are in arithmetic progression, then if they are in arithmetic progression, then each of the successive terms should be added or subtracted by a constant term known as the common difference. That means we should have a common difference. That means if we subtract the consecutive terms, we will be getting a common difference. That is A minus A should be also equal to B minus A. So we just simplify this. We will have 2A is equal to A plus B, or A is equal to A plus B by 2. Now this value of A plus B by 2, when capital A and B are in AP, this is known as the arithmetic mean of A and B, of these two terms. Okay, so now coming back to geometric progression. So how is a geometric progression different from an arithmetic progression? How is a geometric progression different from an arithmetic progression? So as we were discussing, in arithmetic progression, every successive term is added or subtracted by the same constant term. Arithmetic, that's why it's called arithmetic, adding, subtracting. Geometric progression, geometry. So geometric progression, very much similar. Every successive term, for example, should be like multiplied by the same constant term or is increased. Multiplied, let's say, multiplied or divided by the same constant term. Like for example, 1, 2, 4, 8, 16, 32, let's see. Now this is a sequence that I've given to you. Now this sequence, as you see, that you will see that as we proceed with every successive term, what happens? Every successive term is being multiplied by 2. 1 2s are 2, 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32. So it is getting multiplied by the same constant term, which is known as common ratio. We'll learn about that. This is known as a geometric progression, where this time it's not about adding or subtracting. This time it's going to be, in simple words, is about multiplying or dividing by the same common constant term. Another example: 1000, 100, 10, 1, 1 by 10, 1 by 100, and so on. So as you see what happens here, you will see that every successive term is being divided by 10, isn't it? Because 1000 divided by 10, 100, 100 divided by 10, 10, 10 divided by 10, 1, 1 divided by 10, 1 by 10, and so on. So here, what happens in the first sequence? It gets multiplied by 2. In the second sequence, it gets multiplied by 1 by 10, or of course we divide by 10. It gets multiplied by 1 by 10, or we divide by 10 with every successive term. So here also the same concept of arithmetic progression. The term should be constant. Whatever happens with every successive term, the same definite order, the same definite pattern should be followed. The pattern should not be changed, cannot be changed. Then this type of progressions are called geometric progressions. And this constant term, this time, unlike in arithmetic progression, we call that as common difference. This time in geometric progression, since it's about ratio, we will be calling that as common ratio. Common ratio, not common difference. This time we will not be subtracting. We will be dividing. So we will have a common ratio, constant common ratio, constant term, common ratio. So now in general, if I just give you the definition now, it will be something like this. You can note down if you wish. That is a sequence A1, A2, A3, AN. The sequence A1, A2, A3, AN is called a GP. Is called a geometric progression. Is called a geometric progression if, of course, each term is non-zero. If each term is non-zero and if each term is non-zero and we have a common ratio, that is when we divide a term by its preceding term. When we divide a term by its preceding term, we should have a constant term which is known as the common ratio for all values of course, k should be greater than or equal to 1. That means in arithmetic progressions, what we used to do, we used to like, okay, I think the definition is written. In arithmetic progressions, if you have A1, A2, A3 and so on, what do? We should have a common difference. That is, how do we find out that common difference? We subtract. That is A2 minus A1. No? The term subtracted from the preceding term. Similarly, A3 minus A2. Similarly, A4 minus A2 and then so on, AN minus 1. So all these values should be same or should be constant, that is, we should have D as the common difference. Similarly, for geometric progression, when we have A1, A2, A3, A4 and so on, and AN, I think this is done on this right here. have A1, A2, A3, A4, and so on, AN, which is a geometric progression, then what should happen here is this time not subtracting, this time dividing a term by its preceding term, that is A2 divided by A1 should also be equal to A3 divided by A2, should also be equal to A4 divided by A3, and so on. That means AN divided by its preceding term, one term less AN minus 1. They should all give us the same constant term, which is known as the common ratio. Generally we will just use R, so let's just use R. That is known as the common ratio. So this is called as a geometric progression. Okay, so as I said, please keep the concept, understanding of the arithmetic progression at your background. Try to interlink that with the geometric progression. Nothing is different. Of course, there will be slight differences, slight changes will be there, because here we talk of common ratio, not a common difference. So there will be definitely some changes, but the concept is almost the same. Okay, the idea, the general concept. Alright, so with that said, let's look into some terms of a geometric progression. Here also, the first term, of course, we denote by A, or maybe some other letters. As I said, letters, don't really bother about that. That constant term is denoted by R, common ratio. Alright, general term. General term, or we call it the nth term. General term, or we also call it as the nth term. AN here will be given by A into R power n minus 1. So this will be the general term given for a geometric progression, Alright, so that is just a basic introduction. Let's try to do one example. That will help us. You can write down. Let's just try to do one example, that is find the ninth term. Find the ninth term and nth term of the geometric progression 3, 6, 12, 24, and done. Alright, so what is our first term here? A, 3. Common ratio, you divide any two consecutive terms, the term by its preceding, so 6 divided by 3, that will be 2. Similarly, 12 divided by 6, 2. 24 divided by 12 is also 2 again. Of course, it is a geometric progression. Now, let's find out the nth term first. It's all the same, nth term or ninth term, that's up to you. If you find out the nth term, so that will be A into R power n minus 1. So that will be A. What is the value of A? 3. Into R value is 2 power n minus 1. So this is our general term. Please do not multiply 3 2s are 6. Some of you must have just thought, okay, 3 2s are 6, 6 power n minus. We know that that's not possible, isn't it? So don't do that. Okay, so this will remain as it is. This is the general term. Okay, so let's find out the nth term now. Ninth term. So ninth term will be simple. That is, ninth term will be simply A9. That is, I'll just use here 3 into 2 power 9 minus 1. So that's going to be 3 into 2 power 8. 3 into 2 power 8. So that, of course, you can multiply and solve and see for yourself. So this is what we mean by just the concept of geometric progression, how we do, what is it. So as I said, it's not that kind of a very new or a complex topic. Okay. Some hints, like as a note you can write down. We might, when I remember this, I'll just give it to you now. Hi everyone. When I remember this, I'll just give it to you now. Some problems, we might come across some of these problems, so I'll just give it, otherwise I'll forget again. So for example, if you are given sometimes you will come across some questions where you will see there are 3 numbers in GP whose sum is this much, the product is that, find the 3 numbers. Or sometimes there are 4 numbers in a geometric progression, their sum is this, product is that, find out those 4 numbers which are in GP. So if you come across those questions, it will be convenient for you to use the hint that I'm going to give you now. Okay, so if you are given three numbers which are in GP, you can use those three numbers in GP. If you are given, like, if you are made to assume three numbers in GP, then you can assume those three numbers in GP to be as A by R, A R. That will help you. Okay, that will help you solve the question, simplify the question. Okay, that's going to make your life more comfortable. If you are given four numbers which are in GP, plus they give you some properties, and then they tell you to find out those four numbers which are in GP, then that time you can take this. It's not that only if you take these three numbers or these four numbers you will get the solution done and all. No, there are other ways also. Maths, as I said, it can be done in so many different ways. This might just help you. That's why I'm just giving it to you. Okay, this might just help you solve your problem. So, that's all. Okay. Alright, so we have already learned what is a GP, geometric progression. It's very much similar to arithmetic progression, just that it's not arithmetic but it's geometric. Yes, we do not add or subtract, or it doesn't increase or decrease, but it gets multiplied or divided, something like that, so that we have a common ratio. Okay, alright, and the general term also we have already done, and then we have already seen, we have already done with one example. Now, how to find out the sum of n terms of GP? We know how useful is this, isn't it? Sum of n terms of an AP or a GP. We know how useful is this. Like, for example, if you're given 2, 4, 6, 8, 10. If you're given 5 terms which are in AP, not GP, then we know how useful it is to use S5, sum of 5 terms of a GP, that is like 10, 18, 20, 30. But of course here we do not need the formula. We could easily get sum of the 5 terms of an AP as 30. But when the number of terms given are, let's say, 1000, up to 1000, when the number of terms given are like 400 or 500 terms, then we know that we cannot go on adding, and that's when this concept of sum of n terms of a GP comes in, or an AP comes in very handy. But this is going to be slightly different, because as we remember, sum of n terms of an AP, we have two set of formulas, that is 2a plus n minus 1 into d, or n by 2 a plus l. But it really did not depend on the common difference much. But for geometry progression, it depends on the common ratio. What is your common ratio? Is it greater than 1? Is it equal to 1? Is it less than 1? After that, only we have the set of formulas. So we have a set of 3 formulas for sum of n terms of a GP, depending on the common ratio that you get. Of course, definitely you will first find out the common ratio. After that, only you can proceed. That means, in general, Sn, sum of n terms of a GP will be n into a, n times of a, when the common ratio is 1, period. When the common ratio is 1. So it will be simply n times of a. A is the first term, n is the number of terms. Or 1 by 1 minus r power n 1 minus r. Or you will use this formula, that is a into 1 minus r power n divided by 1 minus r, when or if your common ratio is less than 1. That means maybe like common ratio you get 1 by 10. That is less than 1, strictly less than 1, then you will use this formula. Or the other, of course we have only 3 options, isn't it? Whatever value of r you get, either it will be 1, greater than 1, or less than 1, definitely. And the other one will be r power n minus 1, r minus 1. This is when r greater than 1. So don't be confused how to use this formula, because if r is greater than 1, you write r in the front. If r is less than 1, after 1, that is subtracted from 1. If r is greater than 1, you subtract 1 from r. That will help you remember. the formula. So you have a set of three formulas to find out the sum of n terms of a GP depending on the value of the common ratio that you get. Equal to 1, less than 1, greater than 1, you'll be correspondingly using these formulas. Alright, now you must be confused what is going on here. Let me give you an example. Quickly, again, let's do an example. Example will always solve our problems. That is, let's write down, like find the sum of 8 terms of the geometric progression. Find the sum of 8 terms of the geometric progression 3, 6, 12, 24, blah blah blah. So which formula to use depends on our common ratio. So first term 3, common ratio, as we can just divide any two consecutive terms, the term by its preceding term. 2. Now 2 is greater than 1. As we all know, 2 is greater than 1. So which formula are we going to use? You can check your notes that you have just written. That is, we are going to use the formula, since r is greater than 1, it will be r in the front, r power n minus 1, r minus 1. So you will be using this particular formula. So that is, so we are supposed to find out sum of 8 terms. So n is 8 here. What is a? 3. R is 2, power 8 minus 1 divided by r 2 minus 1. So we'll have 3 into 2 power 8, 2 is 4, 4 is 8, 8 is 16. 16, we have 256 minus 1 divided by 1. So that will be 3 into 255. 3 into 255, so that will be 3 5 15, 1 left, 15, 16, 1 left, 765. So the answer is not our concern here. Our concern is just this procedure part. What I meant by giving you those formulas. Formulae. Alright, so it will purely depend on the value of r, which particular Sn to use. Greater than 1, equal to 1, less than 1. Then of course, similarly, just like in arithmetic progression, we also have the geometric mean. That is, if A, G and B, let's say, if these three terms are in geometric progression, then what should follow? Is they should have a common ratio, that is G divided by A should also be equal to B divided by G. That means G square AB, that is geometric mean G is root over of AB. Whereas arithmetic mean A plus if A and B. Where in arithmetic progression, then it was A plus B divided by 2. So this G is called as the geometric mean between of the numbers A and B. And A, that is A plus B divided by 2, is the arithmetic mean of A and B, of two numbers, mean. And we also have one relation, that is relation between, these are just properties, small things which you might just come across, you might need, okay? You will need, not might, you will need in the future also. Relation between geometric mean and arithmetic mean. Relation between geometric mean and arithmetic mean. We'll not go over the derivation of this, I'm just going to give you the relationship. That is, arithmetic mean is always greater than or equal to geometric mean. Arithmetic mean is always greater than or equal to geometric mean. Arithmetic mean is always greater than or equal to geometric mean. Alright? Okay, so that being done, let's go to some properties of geometric progression very quickly. Just like in arithmetic progression, the first property. We have three properties. There are some more, but let's name three. Properties of geometric progression. Just like in arithmetic progression, if you remember, if a constant term is added or subtracted to each terms of an arithmetic progression, then the resulting numbers also form an arithmetic progression. We learned that. Same thing happens in geometric progression also. Same thing happens in geometric progression, but this time not adding, this time multiplying. Okay, so number one, that is if all the terms of a GP, if all the terms of a GP be multiplied, if all the terms of a GP be multiplied by the same non-zero number, by the same non-zero number, then the new numbers also form a GP. Class 10 live, of course, I haven't made up my mind as of yet, but hopefully very soon. If the response gets better and better like this, definitely very soon I'll go for class 10 also. So now this simply means if all the terms of a GP be multiplied by the same non-zero number, then the new numbers also form a GP. For example, let's take one GP, let's say a small geometric progression, let's say 2, 4, 8, 16. 1, 2, 4, 8, 16. Let's multiply this by a constant number, same non-zero number. So let's multiply it by 10. So if we multiply each term by 10, what shall we have? 10, 20, 40, 80, 160. This is our new number, set of new numbers. What this property states that if we multiply by a same constant number with the numbers that we have which are in GP, the resulting numbers that we get also form a GP. I think you can verify that here, because 20 divided by 10, 2, or like 10 2s are 20, 20 2s are 40, 40 2s are 80, 80 2s are 160. Okay, so this is one property which is very useful. Okay, which is very, very useful. The second property is the reciprocals. The reciprocals of a geometric progression are also the reciprocals of a geometric progression also form a geometric progression. The reciprocals of a geometric progression also form a geometric progression. That simply means if again 3, 6, 12, 24, 48. What it means is their reciprocals 1 by 3, 1 by 6, 1 by 12, 1 by 24, 1 by 48 will also be in GP, will also form a geometric progression. Okay, so these are some very good properties. Another property, again another interesting property, is if each term of a geometric progression, be raised to some power, then the resulting terms, also form a geometric progression. That means again, if 3, 6, 12, 24, 48, we have these terms, and then like we raise each term to a certain power, let's say like 3 cube, 6 cube, same, 12 cube, 24 cube, 48 cube, then what you will find is, we'll not go for the verification and all this, you will find that this new terms that you have will also follow a GP or form a geometric progression. Alright? Okay. So these are just some basic things for geometric progression, geometric mean, general term, and so on. So this is what geometric progression is all about. So based on that, let us just try to introduce the exercise, that is exercise number 9.3. We will make it quick. We will not be solving all the questions today. We'll just solve some questions and leave the rest for the second session, second part I mean. Like, you can now open up your textbook. Let me not write down the question. You can open up the textbook and then check for yourself exercise 9.3. As I said, 9.1 and 9.2 are currently reduced from the syllabus, are the reduced part of the syllabus for this particular batch. Okay, so number 1. Find the 20th term and nth term. Find the 20th term and nth term of the given geometric progression 5 by 2, 5 by 4, 5 by 8, and so on. Similar question we have already done, so let's just begin. A, 5 by 2, common ratio, divide any two term by its preceding. So 5 by 4 into 2 by 5 2, 1, 2, 2. So here we have the common ratio 1 by 2. So let's find out the nth term first. That's an, that's a r power n minus 1. So a 5 by 2, r 1 by 2, n minus 1. You can simplify this. 5 by 2 into 1 by 2 power n minus 1. So that will be 5 by 2 power 1, because 2 means 2 power 1, so same, we can add the exponents plus n minus 1, so that will be 5 by 2 power n. 5 by 2 power n. So this is our general term. Okay. Now let's go for the 20th term. That is now 20th term. 20th term. A20 will be simply 5 2 power 20 plus. No need to calculate at 2 power 20. Of course, if you have all the time in the world during the exams, okay, chalo, you can use your calculator, you can multiply, but leave it there. Who is going to do all of that? Only when it's too big, okay? Only when the index exponent becomes very big. Okay. Number 2, quickly. Find the 12th term. Find the 12th term of a GP whose 8th term is 192. Common ratio is 2. Okay, we don't have the first term. So let us assume that first term to be A. Common ratio we have given 2. Now, it says find the 12th term, but to find out the 12th term, we have a power n minus 1. That is a r power n minus 1. We don't have the first term to find the 12th term. Now, that means we need to find out the value of a. To find out that, it is given in the question, that hint, which says, otherwise why would they give you that extra part of the question? That is, 8th term is 192. 8th term is 192. That means a r power 8 minus 1, 192. So a r is 2 power 7 equal to 192. So 192 divided by 2 power 7. 192, if you remember, you can calculate and see. 192. So we can just find out the factors. 2 9s are 18, 6. Isn't it? 2 9s are 18, 6, 2, 48, 2, 24, 2, 12, 2, 6, 2, 3. So we can write that as a equal to 192 can be written as 2 power 1, 2, 1, 2, 3, 4, 5, 6. 2 power 6 into 3 divided by 2 power 7. So 6, 7, 1 cancels. So you have 3 by 2. So our first term is 3 by 2. So Let's calculate the 12th term, a r power 12 minus 1. So that is 3 by 2 into r power 11. So that is 3 into 2 power 10, because 11 minus 1 becomes 10. So that will be 3 into, so 2 power 10 will be how much? 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32, 32 to the 64. That is 2 power 6. So 64 into 2. 64 2s are 2 4s are 8, 2 6 are 12. Again into 2. So 2 is a 16, 1 left is a 4, plus 1 5, 2 is a 2, into 4. 256 by 4, 4 6 are 24, 2 left 4 is a 20, into 2 left 4 is a 8, plus 1 9 10. 1024. So 1024 into 3, 3 4 into 12, 3 to the 6 7 0 3 0 7 2. 3072. This one, of course, this thing depends on your calculation. 3072. Okay. All right. Number 3. Question number 3. The 5th, 8th, 11th terms of a GP are P, Q, and S, respectively. 5th term, P. Let's say a r power 5 minus 1 is P, a r power 4 is P. Then 8th term is Q, that is a r power 8 minus 1 is Q, that is a r power 7 is Q. Then 11th term, if I'm not mistaken, P 5th, 8th, 11, PQS, PQS. So that is a r power 11 minus 1 equal to S, a r power 10 is equal to S. So these are the terms that is given to us. To prove, what we're supposed to prove, Q square is equal to P into S. No problem. What is Q square? Q square, a r power 7, P, a r power 4, S, a r power 10. This is a square r power 14. Here, this is just a multiple, so a square, this is r4 plus 10, 14. Okay, simple proof. A square 7 14, a square r power 14. Done. That's it, the proof. Hence verified, or hence proved, or yeah, whatever we do. Alright, now I'm rubbing it off now. Last question that we will do for today, that is question number 4. Question number 4, it says, 4th term. Question number 4, that's why 4th term. 4th term of a GP is square of its 2nd term. 4th term of a GP is square of the 2nd term. Understanding a question is very important. 4th term is square of the 2nd term. Very important understanding the question. So that is a r power 4 minus 1, 3. A r power 2 minus 1, 1. I'm just reducing one step. Okay, na? A r cube, a square, r square. So 1a, 1a, r square, 1r. So we have r is equal to a. So that's what we have. Alright, so and then what is given is the first term is minus 3. First term a is minus 3. That means r is also minus 3. Okay, because that we already got from this equation. Determine its 7th term. Determine its 7th term. So it's going to be a r power 6 minus 3 power 6. Minus 3 means minus 3 power 1. So it's minus 3 power 6 plus 1, 7. Minus 3 power 6 plus 1, that's going to be 7. Now negative value, power, odd. So as we have done in our lower classes, it's going to be negative. And this one, if you calculate 3 2 9, 9 2 27, 27 2 81, 81 2 43, 3 minus 2187. So that's what we have there, minus 2187. Isn't it? So 3 2 9 9 9 81. 7, 7, 56, 2, 16, 7, 8, 11, 1, 1. Yeah, minus 2187. Alright then, so we'll wind up here for today. So the rest of the exercises we will try to solve it in the next part. We'll try to do it in one part, but I don't think that's going to be possible. So maybe 2 more parts to solve that particular exercise. Let's try. We'll try to do that. So we'll wind up here for today. Thank you all. Yeah, thank you, Sinab. Thank you all also for joining and being a part of this family where we come to learn, not to waste time. So thank you all once again, and all those who have joined, thank you all. I'll see you next time again. Yeah, thank you all of you, straight from the heart. Thank you for being with me. Okay, you have always encouraged me, each and every one of you who have been with me from day one. All of you have encouraged me. That keeps me going. Okay, so that keeps me going. So continue, please continue your support. It's going to be very valuable for me. Okay, it's going to be very valuable for me. So thank you once again. I'll see you next time very soon, maybe in 1 or 2 days, with the second part of the exercise. Alright then, from here I'll say good night.